Hey everyone, so in this video we're going to talk a little bit about web scraping. I see this a lot in like system designer interview uh, videos, but I've actually never implemented one. So this was kind of like my learning process in like building distributed and scalable web scraper. So yeah, this is kind of just like maybe like a memoir slash pretty much the hoops that I went through. So pretty much I pretty much started out with a simple web scraper, and then I kind of made my way up to a distributed and scalable one. So I'm going to go over both designs here. So my first web scraper that I built was pretty much just on my local computer, and I basically wanted to scrape some Japanese listings and do some processing on them. And my process was, I would get the metadata. So I would scrape the metadata, and then once I get the metadata, I'm able to scrape the images or download the images. But the listing metadata and the image metadata, or sorry, the images would go through different two processes, right? So, but for now, let's just focus on the metadata piece, right? So what does a metadata piece do? We're gonna upsert it into our listings table, and then likewise we're gonna send it over to the LLM to translate it. And then once we get that back, we're gonna send that, we're gonna receive that back, right? See translated metadata. And then once we receive that back, we're gonna upsert that over to our translated table or English table. Okay, so that's a process for like the listings metadata. The images has like a different workflow, and so I'll highlight that in red just to show you folks what that looks like. So once we downloaded all the images, we can actually I'll just start from one again, but technically this process would kick off after two here from that first one. But after we downloaded the images, we pretty much want to upload the images. And then once we upload the images, we'll receive back like some S3 keys, which is pretty much kind of like the location of the image. And then from there we can upsert those over to the images table. So that once we want to serve our images, we can use that metadata along with the S3 location for that. And yeah, that's kind of the process that I first did. I was getting around like 1.5 listings a minute. And yeah, you can see that's like really slow, right? So if you had like 10,000 listings, that's pretty much going to be like 15,000 minutes to process all those listings. So in the next segment, I'm going to show you guys how to scale this up using Redis queues. Okay, so why do we need queues? So this is my listing processor diagram here of the different steps that happens in the script. But essentially, like the image processor is something similar where it has three queues here. And yeah, so what it basically does is that it gets the listings first from this main queue, and then it's going to enqueue it into this processing queue. And while it's being processed, we're going to make an API called a Zeit, and that's where we get our scrape metadata back. We're going to create a hash from it, send that metadata to an LLM for translation, and then we receive that metadata back, that translated metadata back, and we're going to upsert both the raw metadata and the translated metadata into their respective tables. And then afterwards, we're going to remove it from the processing queue. And yeah, so the first reason here is for parallelism. So see, I can't even spell. But essentially, if you have like a million listings that you need to work on, you can pretty much spawn a million workers, but it's probably not going to be the best thing for the site, right? Because you're going to hit them with a lot of API calls. And so what essentially you want to do is you want to maybe experiment with a few workers, right? And slowly scale up to an amount that you find fit. But so more workers will mean more throughput, meaning more listings you could process, right? So that's one of the main reasons. The second reason is for rate limiting. And a lot of API providers, they have rate limits. So I think LLM services, they're pretty lenient. Like you can do like hundreds of API calls a minute, and I think same thing with Zeit, and same thing with databases. But there's third parties. I think like in banking, I was speaking to a fintech developer, and he was saying that his like one of the banks that he's working with, I think it was like Wells Fargo or something. They have the strictest rate limits out there. I think it was something like 30 API calls a minute. And so, imagine if you have like a lot of transactions, right? How would you would need to stagger those transactions accordingly to that rate limit. So then, maybe you'd have to write a rule saying, process only 10 transactions every 20 seconds with exponential back off and retrying. And yeah, so so the third reason you would want Redis queue is for the ability to track failures. So say you ran out of Zeit credits or Open AI credits, right? Like your process is going to fail because you're not going to be able to upsert your listings or your translations. And so but when it fails at that stage, right? When it fails at either of these, your listing is still going to be in the processing stage. So you still have that metadata of your listing. So you still have the URL of your listing that needs to be, processed. And that's like, so then maybe you can stop your process there, look at your logs. Oh, I ran out of credits, right? And then go back to Zeit or OpenAI and then refill your credits and then restart your process. And then your process could then like, process your processing queues and your failed queues first before going back to the main queue. So yeah. Here you can see I have my VM running a worker manager script. So essentially 2 workers are running right now, 2 listing workers and 10 image workers in parallel. And you can see I'm getting around 31 listings a minute, which equates to around 15 listings per minute per worker. And then likewise for the images, I'm getting around 30 to 35. So 30 image is minute per worker. Yeah, and I'm going to keep covering that, but yeah, that's pretty much a script running. Yeah, CPU usage, I don't know why it's so high. I think I just have to restart the VM. Usually it hovers around 10 to 20% on one CPU, and then the memory usage is around 1 to 2 gigabytes from what I've noticed. And yeah, network usage is I think where most of the processing comes in because of all the API calls you're making to the databases, the scraper, the LLM service, and yeah, that's about it. Yeah, scalable web scraping in a nutshell.